Going on, guys? Let's look at this problem right here. This question is asking a railgun consists of two parallel wires connected by a third perpendicular wire. These three wires form a series circuit in which current flows up one wire across the perpendicular wire and back down the third wire. The perpendicular wire is allowed to move and is pushed forward by a magnetic interaction. If the three wires carry 78.5 kiloampere of current, are of radius 8 cm and the two parallel wires are 39.9 cm apart, determine the force in N acting on the wire. Assume the parallel wires are semi-infinite. You do not need to account for any other geometry or for the finite thickness of the perpendicular wire. Treat it as a line current. Okay. Now let's go ahead and draw a diagram for this one. Here we have two parallel wires. Okay. Let's say this is our wires, and here we have another wire. Okay, and these two are connected by a third wire that is going like this, and let's say current is going in this direction, and this is forming a series. Okay, and the radius of this wire is given by R. Let's say this is R is the radius, that is 8 cm, and these two are apart by 39.9 cm. Okay, 39.9 centimeter, and we are trying to find the force exerting on this perpendicular wire. Now to find this one, also we have to know, let's say this is our x distance from here to here. First we are going to consider one wire, and we are going to calculate the force exerted by one wire, and then we are going to multiply it by 2. In that way we will find for two wires. Okay, because both of them are going to exert force on the same direction, and the magnetic field is inside. Now let's go ahead and calculate this one. To find this one, we can use this equation. This is for one wire. df is equal to I times mu naught I divided by 4 phi x. Okay, and dx is small part of this one. Okay, now this is our equation. Now our question is to find out the force, so we have to integrate both sides. If we integrate, this is going to become f, and here if we integrate, this is going to be mu naught I square over 4 phi x dx. And if you notice, we are integrating this one with respect to x, so everything other than x is going to be a constant, so we can move these three parts to the front. So this is going to be mu naught I square over 4 phi, and we are going to integrate 1 over x dx, and if we integrate this one, this is going to give us ln of x, and also we have to put the limits of integration. This is going from the radius of the wire, that's the lower limit, and the upper limit is going to be, let's say this is a is equal to this one, so upper limit is going to be a minus r. And let's go ahead and plug this one. Here we're going to have r, this is our a minus r, and if we integrate this one, this is going to give us mu naught I square over 4 phi, and here we are going to have ln of x, that's going from r to a minus r. Now we are ready to plug our values. Now let's note down the given values. Here we have the current, that is 78.5 kiloampere, and we have the radius, that is 8 centimeter, and in meter that's going to be 0.08 meter, and here we have the apart distance. Let's call this one a is equal to 39.9 centimeter. In meter that's going to give us 0.399 meter, and that's all we have. Okay, now let's go ahead and plug it here. Mu naught, and also mu naught is 4 phi times 10 to the power of minus 7 henries per meter. So this is going to be 4 phi times 10 to the power of minus 7 times I square, that's going to be 78.5 times 10 to the power of 3, because we have kilo right here, so this is going to be 10 to the power of 3 square. I need some space. So let's move this one a little bit this side. Okay, let's begin here. So this is going to be mu naught, that's 45 times 10 to the power of minus 7, and the current is 78.5 times 10 to the power of 3 square, and in the denominator we have 45, and here we have ln of x, that's going from r to a minus r. R is going to be 8 centimeter, in meter that's going to be 0.08, and a minus r is going to be 0.399 minus 0.08, and that's going to give us 0.319. So the upper limits of upper limit is going to be 0.319, and if you calculate these two cancels each other, this one and this one cancels, and if you calculate this one, you will end up with 852.34 Newton. Now this is only for, like, this force is exerted by one of this wire. Now here we have two wires, and both of them are exerting force in the same direction. So the total force F total is going to be 2 times of this one, 2F. So 2 times 852.34, that's going to give us 1704.68 Newton, and that's going to be the final answer. I hope this helps. Thanks for watching.